Let's look at how to achieve a quality root pass weld on carbon steel pipe using RMD. We'll demonstrate welding both fixed and rolling pipe, starting with the 1G rolled position. Start the arc in the center of a tack weld, positioned at around 1:30 to 2 o'clock. Hold the gun perpendicular to the pipe with a 5 to 10 degree drag torch angle. Use a 3/8 to 5/8 inch stickout. In some cases, this may require a recessed tip to help maintain the correct stickout. Establish the weld puddle. Then position the wire in the center of the puddle as the pipe rolls away from you, effectively dragging the weld puddle. If your gap is greater than 3/16 of an inch, you may need to weave the electrode slightly across the gap and up the sidewall to bridge it. As the pipe moves, make sure the weld is tying into the sidewall with no voids. When the wire speed is properly positioned in the weld puddle and the travel speed is correct, the arc sounds like this. Even though the RMD process looks colder than the typical short arc process, the weld puddle fuses into the sidewall and penetrates the joint due to the calm metal transfer and stable arc. The resulting weld will be fully penetrated with consistent bead shape and sidewall fusion. The root pass will be thicker than conventional short arc with a flat face. A characteristic of the RMD process is the tolerance to wire stickout. In some cases, welders need to increase stickout due to joint accessibility. The RMD process will maintain the same arc length and produce the same weld result as the stickout is changed. This is also a benefit for inexperienced welders that have problems holding a constant stickout. If the joint is misaligned, continue to concentrate the arc in the center of the joint. You do not need to favor the high side of the joint. The key is to let the arc do the work. If the wire is positioned on the leading edge of the puddle, similar to traditional short arc technique, the wire will push through the joint. The arc will stutter and sound like this. The resulting weld will have greater penetration and some spatter will be produced inside the pipe. If the travel speed is too slow and the wire is positioned too far back in the puddle, the arc becomes unstable and it sounds like this. The weld face will become convex, which may require grinding to prevent cold lap on the next pass. Now, let's move on to welding the root pass in the 5G fixed position. You'll begin your weld at 12 o'clock, and as with welding in 1G, you'll start the arc in the center of a tack weld, using a 5 to 10 degree drag angle and a 3/8 to 5/8 inch stickout. As you start to weld, stay in the puddle and move the electrode back and forth across the gap using a half moon motion until gravity starts to push the puddle down the joint. This will happen at approximately 1 o'clock. It's easier to use a downhill technique with the RMD process when you're welding the root pass. Once gravity takes over, you can stop weaving and concentrate the arc on the center of the weld puddle. Move down the joint until you reach the 5 o'clock position. At 5 o'clock, you can use a slight side-to-side motion until you reach 6 o'clock. This will flatten the top of the weld bead and help to eliminate grinding. End the weld at the 6 o'clock position by moving the weld puddle onto the feathered tack weld. If you stop welding in the root, you may get a pinhole. To improve tie-in and eliminate the pinhole, feather the weld crater before restarting the arc and resuming the weld. Look closely at the finished root pass weld made with RMD. The RMD root pass is flat on the face of the weld and tied into the sidewalls. The root reinforcement will be approximately 1/16 inch and tied into the toes. The root pass will be thicker than a conventional short arc root pass. This may eliminate the need for a hot pass. There's simply no easier way for a welder to achieve uniform, high-quality root pass welds than with the RMD process.